Okay, we're going to talk about two special triangles, but today I said I was going to split it up into two parts, so we're just going to talk about one special triangle today. I want to make sure that you know how to do this one, and then tomorrow we'll do the second special triangle. It's all the same section. It's still section 8.3, but we're just going to do one at a time. I just didn't want to cram it all in one lesson. I just wanted to make sure that you knew how to do this. So the first triangle looks like this, and there is something special about it. It's not just an ordinary triangle, and it's not just an ordinary right triangle. I mean, it looks like a right triangle, doesn't it? But it's not just an ordinary right triangle. What do you think might be true about this triangle? Just kind of looking at it, what's your guess about the lengths of the sides, basically? What does it look like might possibly be true about this side here and this side down here? Just take a guess. I mean, what does it just look like to you? What's that, Lonnie? You just said it. I thought you said something. They're equal. Didn't you say that? Oh, you said that. Oh, okay. You must be throwing your voice or something. Okay, they are equal to each other. So this and this are equal to each other. Why? Because I said they are. All right, and I made it that way. I made it so that those two are equal to each other. Now, this is something that we've learned in the past, so it's something that we can figure out. Tell me something about that angle and this angle. They're what? They're equal to each other. Exactly right. I don't know if you remember, but back in the day, back earlier in the year, we talked about what do you call this triangle, by the way, when you get two equal sides? It's what's that? Isosceles. Very good. Okay, it's an isosceles triangle. And on an isosceles triangle, the angles that are opposite the two equal sides, they're going to be equal to each other. Do you remember that? If I have an isosceles triangle, the opposite angles are going to be equal to each other. So this angle right here is definitely equal to this angle down here. Now, if this is a right triangle, that's 90 degrees, you should be able to tell me exactly how many degrees both of those angles actually are. And they're 45. How'd you get 45 out of that? That's right. Do you remember that the acute angles of a right triangle are complementary? All right, said a mouthful there, but did you hear what I just said? The acute angles, all right, it's these two angles right here, of a right triangle are complementary. What does it mean to be complementary? They do what? They add up to 90 degrees. So if these two add up to 90 degrees and they're both exactly the same, then what do you do to find each of them? You just take 90 and just divide them by 2 because they're both the same, and that gives you 45. So this angle right here is 45 degrees, and this angle right here is 45 degrees. This is a special triangle, and we call this, it's not much of a stretch, but we call it a 45, 45, 90 triangle. Some people might call it 45, 45 right triangle, but this book says 45, 45, 90 triangle, and that's what we'll call it. Okay? So all we've done right now, we haven't even learned much right now. Everything is old stuff, right? We haven't really learned anything new yet. But I just wanted to set this up for you so you know what we're dealing with. We're dealing with a 45-45 triangle. All right, let's scooch this down here, and then we're going to really learn what I want you to learn today. All right, we'll put this up here, and let's just make it look a little more interesting, add some color to it. Okay, there's a right angle. This is 45, and this is 45. Now, we already said, what if I just gave it to you like that? What if I didn't even tell you that those two sides were equal, but I told you this was 45 and this was 45? What do you think you can tell me about this side and this side? Yeah, they're equal. So if the two angles are equal, the opposite sides must be equal as well. Do you see the difference between what I did earlier? Before, I told you the two sides are equal. That means that the angles are equal. This time, I told you that the two angles are equal. What does that mean? That the two sides are equal. You got it? So I got a 45, 45, 90 triangle. Let's do this. Let's kind of come up with our little formula that I'm going to show you. We're going to have to memorize a formula for this. On this triangle, this special triangle, we only have to memorize one little formula. On the other triangle, the one we're going to do tomorrow, we're going to learn two different formulas for it. Okay, that's why I didn't want to put it all in one lesson because you'd have to learn 3 of them. I'm just going to do one here, and then we'll do 2 tomorrow. Okay, so we're going to come up with the formula on our own. So let's say I call this x and I call this x. Let's find out, we'll call this h. Why did I use h? That's a weird thing to use. Why would I use h? Hypotenuse, good. Okay, so we'll use h for hypotenuse. So watch what's going to happen here. Let's take a look at, yeah, let's do it like this. I was thinking something else, but let's do it like this. So if I wanted to do Pythagorean theorem, how would I set this up with Pythagorean theorem? If I wanted to like solve for h, Okay, I would go what? Yeah, but what is the a here? It's x, isn't it? Plus what? Another x, right? Because they're the same thing, right? They're the same exact sides. That's why I called them both x. Does that make sense? All right, equals what? H squared. Now let's do this. That's a 1x and that's a 1x, isn't it? Add these up. What's 1x squared plus 1x squared? 2x squared, isn't it? And that equals what? H squared. Okay? And let's do this. Let's solve for h. Let's get h by itself. How would I get h by itself right here? Square root. We've done that a bunch. Square root that. So let's see what h is equal to. Now, both of these things are under a square root. So I've got a square root of 2. Everybody see that? Watch. I've got a square root of 2. What else do I have under a square root? Square root of what? X squared. Well, let's deal with this one first. What is the square root of x squared? It's just x. Can you do anything? Can you simplify the square root of 2? No, you can't. So watch. It's the square root of 2 times x. Now, what does that mean to me? Well, it means a lot, actually, because look, these are your two legs. Both of the legs of this isosceles triangle are exactly the same. Do you agree? All right, so what is the hypotenuse? The hypotenuse is what? The square root of 2 times whatever that number is right there. All right, so the hypotenuse is the square root of 2 times one of those legs. That's the relationship between the hypotenuse and the sides and the legs of the triangle. Are you watching this? Daniel, is your head up? Okay, my eyes up here. Well, it wasn't when I said your name. Oh, okay. How's it doing? Is it doing all right? Okay, good. I'm glad everything's fine there. Self-examination of your elbow. Good. So let's take a look at this. The hypotenuse is the square root of 2 times one of the legs. That's really, really important. Let's write that down, in fact. Let's say it. The hypotenuse equals the square root of 2 times one of the legs. Now, when is this true? This is only true when you have what kind of a triangle? Not just any right. A 45, 45, 90 triangle. When you have a 45, 45, 90 triangle, the hypotenuse is always the square root of 2 times one of the legs. And you say, well, who cares about that? I do too, Daniel. I'm glad you care. Because watch. What if I gave you this and I said, this is 45 and this is 45, and they're degrees. And here's what they're going to do on the homeworks, okay? We're going to do a couple different ways with this, okay? But let's say they tell you that was 7, and that's all they tell you, okay? And they ask you to solve for whatever, h. We'll call it h again. What if they ask you to solve for h without doing any math? Put the calculator away. Without doing any work on the calculator, without doing Pythagorean theorem, we just learned something, and it's right there, and it's in blue, and it's in a box. And that's what I want you to use. I don't want you to put it into a calculator and give me some decimal number. I want you to learn this, because this is easier. You guys some of you guys anyway, you kind of balked at that Pythagorean triple stuff, all right? You're like, okay, he taught that stuff, but that's too confusing to learn, so I'm just going to do Pythagorean theorem, the thing that I've known for a couple years now. All right, listen, I'm telling you, this is a much, much, much better way to solve for h than doing Pythagorean theorem on this. You just have to learn something. You got to memorize a couple things, okay? You got to memorize what the relationship is between the hypotenuse and the leg. And what is it? It's the square root of 2 times one of the legs. So it's very easy, okay? It's super, super easy if you just have this thing memorized. So what is it? It's the square root of 2 times what? 7. And how do you write that? Yeah, we write it 7 square root of 2. And that's it. That's the answer right there. That's how I want you to leave the answer, okay? I want you to leave the answer just like that. I don't want a decimal. I'll write it on here. So you can't say, well, you never told us. Well, I did because, whoops, I can't write an I. How about this? Watch. No decimals. I don't want any decimals. I want you to keep it the 7 squared root of 2. Everybody see that? I will not accept. If you stick this into a calculator, you do Pythagorean theorem, you stick it into a calculator, it's going to be wrong. All right? I don't care if the decimal is actually the same thing as this. I'm going to mark it wrong because I'm telling you I don't want any decimals. I want you to write it as a exact answer. All right? What if I asked you to solve for x? What would x be equal to here? That's super easy too, isn't it? Because look, it's 45, 45, so I know both those sides are the same, right? So I know this is 7, and that's got to be 7 as well. Does that make sense?
Is this right?
It's pretty easy, isn't it?
Check this to see if this is right. This number 1.
Well, let me do a little bit more here. I got more stuff to do. What if I did this? I'm going to make this just as easy. This is no more difficult, okay? I'm not trying to make this difficult. So let's say this. All right, this is the information that they give you, and they want you to solve for x, and let's not call this h anymore. Let's just call it a, and let's just call it y. Call it x and y. Okay, that's the information they give you. They don't give you anything else, and they say solve for x and y. So what's probably the one of the, well, they're both pretty easy. Solve for x is easy, probably. What's x? It's 5. What's y equal to? It's just 5 square root of 2. That's all it is. You just take the leg and you multiply it by the square root of 2. You just stick it next to each other. That's not the square root of 10, though, is it? All right, it's what? 5 square root of 2. This is not the square root of 10 because this 5 is just a regular whole number 5. And you can't really multiply those two together like this. If it was the square root of 5, then guess what? This would be what? The square root of 10. Okay? Make sense? All right. Let's see if you're really listening. Let's say these two are equal. So again, it's a 45, 45, 90, isn't it? If those two sides are equal to each other. What if this was the square root of 7 and they asked you to solve for x and y? Well, x is the easiest one. What's x going to be? Square root of 7 is going to be the same thing, isn't it? It's really blinking a lot, isn't it? Is it kind of flashing more than normal, or does it look okay? It's always been like that, has it? Okay. So this is square root of 7. What is y then? Okay, it's the square root of 7 times the square root of 2, but you should simplify that. How do you multiply those, or can you multiply those together? Did you do any of this stuff in Algebra 1? You didn't do any of that stuff in Algebra 1? You should have. Watch. Here's a rule. I'll show you. Shh. Don't comment. Okay, I know I asked you, but it was rhetorical, actually. All right, so watch. Here's something from Algebra 1 you should learn. The square root of a times the square root of b is equal to the square root of a times b. Does that make any sense? What does that mean? That means the square root of 7 times the square root of 2 is the square root of what? 7 times 2, which is what? Square root of 14. All right? So when I multiply two square roots together, I can just multiply the two numbers and stick them under a square root. Everybody see that? Okay, it's pretty easy, isn't it? Now, you couldn't do it. What if it was 7 square root of 2? Can you multiply them together? No, that would be your answer if it was 7 square root of 2. But if you had a square root times another square root, you just multiply the two numbers together, stick it under one big square root, and then that's all you have to do. All right? So if this side was square root of 7, then this hypotenuse is what? The square root of 14. And that's how I want you to write your answer, just like that. It's pretty easy, isn't it? Yeah. Here's the part that gets a little bit tricky. And you knew that was coming, didn't you? Yeah, it always does. But let's think about this. Let's go a different color here. Let's go orange. What if it's a right triangle and it's 45, 45, right? Because I've got the two equal sides. What if they don't tell you the side, but they tell you the hypotenuse? What if they told you that this was, I don't know, 10 square root of 2? That's right. This would be 10 and this would be 10, wouldn't it? Now, how did you get from the hypotenuse to the leg? Remember what the formula was. The hypotenuse, and you should write this down. The hypotenuse is the square root of 2 times one of the legs, right? But this time, what do they tell you? They tell you the hypotenuse, right? So watch what I'm going to do. And we'll just call this x, and we'll call that x. Is that all right? So what is the hypotenuse? It's 10 square root of 2. What does that equal? It equals the square root of 2 times one of the legs. Square root of 2 times one of the legs. What's one of the legs? X. How do I get x by itself? Divide it by the square root of 2. Do you see it? So if they give you the hypotenuse How do you get the leg? You don't multiply by the square root of 2. You do the opposite, which is what? You divide by the square root of 2. Everybody see that? And so look what happens. Then you got your 10 right there. And now it makes sense, doesn't it? Because if I started off with 10, what would the hypotenuse be? It would be 10 square root of 2, wouldn't it? All right, but if I given the hypotenuse, how do I find the leg? I divide by the square root of 2. So it looks kind of complicated when they give you a hypotenuse like that, but it's actually pretty easy, especially if they put a square root of 2 there, right? Just divide it by square root of 2 and you got your leg. So if that's 10, that's got to be 10 as well. Does that look all right? Here's probably the hardest one that you're going to see. What if they made this like, I don't know, let's pick a weird number like 17. And then we said that those two are equal to each other like that. They could do it two ways. They could say that these two sides are equal, or they could stick a 45 up in here. All right, it means the same exact thing. What if this was 17? What in the world would this side be right here? We'll call that A, and we'll call that A. How would you find the leg? Now, they gave you the hypotenuse, didn't they? If they give you the hypotenuse, how do you find the leg? You divide it by the square root of 2. Everybody see that? Remember, the hypotenuse is the square root of 2 times one of the legs, right? In this case, it's A, isn't it? So how do I get A by itself? I divide by the square root of 2, right? So how do I get A? It's what? It's 17 divided by the square root of 2, right? Yeah, I almost hate to tell you can leave it like that, but as far as I'm concerned, you could probably leave it like that. When's this class over? It's Wednesday. It's 3:20 or 5 minutes. Doesn't seem like your Algebra 1 class was quite up to par with the square root stuff, and I just hate to spend a whole lot of time teaching the square root of stuff. But I'll show you. We got 5 minutes. Let's do it real quick. I'll let you keep it like this for now. Okay? In here, I'll let you keep it like this. But when you get to an Algebra 2 class, you're not going to be able to keep it like this. And I'll show you. I don't know if you remember this at all. Do you remember, this is not simplified. Why is it not simplified? Do anybody remember that? Because you got a square root where? On the bottom. Okay? You got a square root on the bottom. So we wouldn't get rid of the square root on the bottom. I'll just show you real quick how we do that. I'm not going to go through a big explanation. But what we do is we multiply the top and the bottom by the square root of 2. What allows me to do that? What is the square root of 2 divided by the square root of 2? It's just a 1, isn't it? Anything divided by itself is a 1. So am I really changing the value of this at all? No, I'm not. But why in the world would I do that? How does that help? Well, watch. What is the square root of 2 times the square root of 2? Do you remember that rule we had before? Multiplying together, stick them under one big square root. So what would that be? It would be the square root of 4, which is 2. And look what we just did. We just got rid of the square root on the bottom, didn't we? Okay, why do we have to get rid of the square root on the bottom? I don't know. Somebody a long time ago made up this rule that says this is not simplified if you have a square root in the denominator. All right? I think it had to do with the days way before calculators and stuff, and you couldn't divide by a square root of 2. Anyway, I don't know all the history. It has something to do with that kind of thing. But a lot of times teachers are not going to let you leave it like this. As far as I'm concerned, that's perfectly fine, to tell you the truth. Yeah, I'll just let you keep it like that. Problem, though, is when you look in the back of the book, or if I read off the answers, they may not read it off like this. Okay, they'll probably read it off. Now, what would this be? 17 what? Square root of 2. So that right there, try it in a calculator. Put this into your calculator and put this one in your calculator, and I bet you get the same exact decimal. All right? In fact, I just happen to have a calculator. Let's do it. Watch. 17 divided by the square root. Oops. Yeah, that's right. Square root of 2. Let's see what that comes out to be. It comes out to be that number, 12.02. Now, let's try this one right here and see if we get the same thing. This is 17 times the square root of 2. Right? And then what do we do with that? Divide it by 2. Let's see if we get the same thing. Look at that. It's exactly the same, isn't it? So would you agree that this thing here is equal to this thing right here? Yeah, it just showed you on the calculator it was. This is really how the book is going to write your answer. If I read it off from the workbook, that's how they're going to write the answer. As far as I'm concerned, you can just keep it like that. Okay? Feel free to just keep it like that. Okay? I pretty much gave you every situation with a 45, 45, 90 triangle. Tomorrow we're going to learn another triangle. It's called a 30, 60, 90 triangle. All right? And there's two things that are different, not just one. Or two formulas, I guess, if you want to call it that, not just one like we had today. But I think that's good enough. All right, let me see. Let's see. You're not going to do every problem. You're only going to do 1 through 8 on this. Okay? So on this worksheet, which is section 8.2, isn't? No, it's 8. Yeah, that's right. Is it 8.2? Oh, I wrote it wrong on my lesson plans. I should have written 8.3. I wrote 8.2. So we're just doing 1 through 8. That's all you're doing on this worksheet. Grab the worksheet before you go, and that's your homework for tonight. Just 1 through 8.